Hi, I'm Clara Rus from Project Finder, Fairness and Intersectional Non-Discrimination in Human Recommendation, a research project funded by the European Union that offers free and open methodologies, tools and training. We offer a free course on fairness, accountability, transparency and ethics of AI-based human recommendation, and this video is about fairness in score-based rankings. Did you know that ranking systems can be used in the recruitment process? In this lecture, we will show how ranking systems can help automate the recruitment process, what public datasets are available for this kind of task, and what possible harms can arise from using ranking systems in recruitment. We will also provide possible solutions to these harms. Ranking systems can help automate the recruitment process by giving a recruiter a ranked list of candidates given a job description or a set of minimum qualifications. However, the recruiter is the final person that makes the decision. In a ranking system, the candidates are ranked based on a computed score in decreasing order, having at top positions the most qualified candidates. The score should reflect the relevance of the candidates given the job. The ranking can then be evaluated in both terms of fairness and utility, meaning that the ranking should be both useful and fair towards the candidates. How do you define a ranking function that outputs a useful but fair ranking? For example, the Zinc dataset, which is an anonymized dataset of real users enrolled on the Zinc platform, offers information about the candidate's work experience, education, and popularity on the platform. One way to design a ranking function is to compute a score for each candidate by using the sum between education and work experience multiplied by the popularity on the platform, creating a ranking that we can see on the right. However, the data representing the candidates, which is also used to create the ranking, might encode pre-existing bias, generating a biased ranking, which might enforce already existing stereotypes that could lead to discriminatory outcomes. For example, the wage gap. If the data contains information that systematically disadvantages one group, females being paid less, the system could perpetuate this inequality. Thus, the focus of this lecture is on solutions that can be applied to mitigate these problems. One solution would be to not give access to sensitive information. But is this enough to just ignore the gender of the candidates? The answer is no, as data can be proxy for gender, so without having access to gender of the candidates, the system can perpetuate discrimination against one group, as the data representing the candidates might be a proxy to the gender. So how to tackle this problem? There are various fairness methods that can be applied in the pipeline of such system, including pre-processing, in-processing, and post-processing. Pre-processing are applied on the data representing the candidates, in-processing are applied on the ranking function, and post-processing are applied on the generated ranking. In this lecture, we will provide an overview of state-of-the-art mitigation methods. Some examples include counterfactual fairness, how to create a ranking function that is fair, and what diversity constraints can be applied on the generated ranking. Moreover, we will also look into mitigation methods that account for intersectional group, because it is very important to consider intersectional groups, as candidates belonging to multiple sensitive groups are more likely to be discriminated. Achieving proportionality for each gender subgroup does not guarantee a fair representation for a subgroup defined by the intersection of both attributes. In the end, we want the system to produce a fair ranking, a ranking that is more diverse and that does not favor one group over another. But how do you measure fairness? We will also introduce ways of evaluating the fairness of a ranking, and more information is available in the description of this video, including various ways of assessing the entire course.